All right, let's dive into one of the absolute cornerstones of Cisco's ACI, access policies. And look, I know what you might be thinking, another configuration topic. But trust me, this isn't just about clicking buttons. This is a whole new way of thinking about network connectivity, especially at scale. And getting this right from the start, it's everything.
Seriously, just think about this for a second. You've got 1,000 network ports to set up. Servers, hypervisors, you name it. How do you do that and make sure every single one is perfect? Because doing it by hand, man, that's not just boring, it's a total recipe for disaster. It's human error just waiting to happen. You type in one wrong VLAN, forget one little protocol setting, and boom, you're spending your Friday night troubleshooting an outage. This is exactly the problem, the high-stakes game that ACI access policies are built to win.
Okay, so here's how we're going to break this down. We'll start with the why, the problem of scale. Then we'll get into the weeds with ACI's policy building blocks. After that, we'll see how to connect that policy chain. We'll look at a really practical example with VPCs, and finally, wrap up with some crucial design rules for success. Sound good? Let's go.
All right, first up, the problem of scale. To really get a handle on this, we have to leave the old world behind. That whole box-by-box, command line grind. ACI's whole deal is to flip that on its head. We're talking about swapping out all that manual, repetitive work for a centralized, automated framework built on reusable policies.
And the answer to that challenge is the ACI policy model. Think of it like a blueprint for your entire network. Instead of you, the network admin, having to SSH into a switch and configure an interface, a global admin can define these high-level policies for, protocols, settings, the whole shebang. The key here is that these policies are modular and totally reusable. You build the blueprint once, and then you can apply it consistently over and over, across any switch, any port in your fabric. That right there, that's how you get consistency and scale.
So if we're going to build this blueprint, we need to know what it's made of. Let's talk about the components, the actual building blocks. I like to think of them as Lego bricks. In this section, we're going to dump out the box and look at each piece. And seriously, if you can master these individual concepts, the whole system just clicks into place.
So taking a look at this high-level view, you can see access policies are kind of bucketed into a few main categories. You've got switch policies, interface policies, pools, and domains. Each one has a super specific job in defining how a device actually connects to the fabric. Now, we're not going to boil the ocean here. We're going to focus on the most important ones, the ones that make up that core chain of configuration.
Okay, first piece, switch profiles. This one's pretty easy to get your head around. Its whole job is to answer one question: where? As in, where are we applying this configuration? A switch profile is really just a container, a group. You use it to pick one or more leaf switches. Maybe it's just a single leaf, or maybe you're grouping two of them together for a VPC pair. This is our first step, targeting the hardware. So we've picked our switches. Now we got to get more specific. That's where the interface profile comes in. If the switch profile was the where, this is the which ports. Inside one of these, you'll create something called an interface selector. And that's where you define a specific port, like Ethernet 1/10, or even a whole range of them. So we've gone from the switch down to the actual physical interfaces.
Okay, now for what I think is the most powerful piece for reusability, the interface policy group. This is the how. How should these ports actually behave? This is a template. It's a bundle of all the nitty-gritty settings, like LACP for your port channels, CDP or LLDP, link speed, all that stuff. And the beautiful part is, you create it once. Let's say you make one for your VMware ESXi hosts. Then every time you connect a new ESXi host, you just grab that same policy group and apply it. It's amazing. Last but not least, we need to connect our port configuration to the actual network, the VLANs. This is the what resources piece of the puzzle. It involves two things, domains, and this thing called an attachable access entity profile, or just AAEP. Everybody calls it an AAEP. Think of the AAEP as a bucket that you throw all your configured interfaces into. Then the domain is the bridge that connects that bucket to a specific pool of VLANs. This is the step that basically says, yep, these VLANs are allowed on these ports. Super important.
All right, so we've seen all the Lego bricks, now let's snap them together. This is where you're really going to see the power of this model. We're going to build the whole chain, end to end.
Okay, here it is, the whole shebang. This diagram shows the complete chain of command, linking everything we just talked about. And yeah, I get it, it looks like a lot at first glance. But trust me, there's a really clear, logical flow to it. We're going to walk through it right now, step by step, so you can see exactly how it all connects.
Let's just trace the path. Step 1, the switch profile picks our leaf. That's the where. Step 2, linked to that is the interface profile, which picks the ports on that switch. That's the which.
Step 3, those ports get linked to an interface policy group. That's our template with all the settings, the how. Step 4, that policy group gets tied to an AAEP, our bucket for grouping interfaces. And finally, Step 5, the domain connects that AAEP to a VLAN pool. That's the what resources. See? Each piece has its own distinct job in the chain. Okay, enough theory. Let's talk about something real. We're going to see how this policy model completely changes the game for a task that, let's be honest, can be a real pain, configuring a VPC. This is a perfect example of policy-driven networking in action. Just look at the difference here. The old way, the traditional NXOS way, you're manually setting up peer links, keep alives, making sure dozens of little parameters match up perfectly. It's a nightmare for configuration drift and silly mistakes. But in ACI, forget about it. The peer link is gone, the keep alive is gone, the fabric handles all that complexity for you. The whole thing is just driven by a reusable policy. You get perfect consistency every single time.
And this is why it's so much simpler. The ACI fabric itself, the whole spine and leaf architecture, is the peer link. It handles all that communication between the two leaf switches in the VPC pair. You just don't need those dedicated physical cables anymore. This makes the physical design so much cleaner, and the configuration, well, it's just way easier. The fabric does the heavy lifting.
So here's the absolute kicker. In ACI, something as complex as a VPC is just another policy group. That's it. You just create a VPC policy group instead of a regular one, and then you apply it to a switch profile that happens to contain 2 switches instead of 1. The model, the logic, the entire workflow, it's exactly the same. Now that is elegant. That's what scalability looks like.
Okay, we get the what and the how. Let's finish up with the how to do it right, because if you follow a few simple rules right from the start, I promise you, you will save yourself a world of pain later on. This is how you build a fabric that stays clean, organized, and manageable, no matter how big it gets. I need to stop here for a second and really drill this point home. This quote is probably the single most important thing you'll hear about access policies. You cannot rename these objects once they're created. That's it. The only way to fix a typo is to delete the whole thing, which can absolutely impact traffic, and start over. So please, believe me when I say your naming convention isn't optional. It's not a nice to have. It is the foundation of a sane and stable ACI deployment.
So what's a good naming convention? It's really simple. Just follow these rules. First, one switch profile for every single leaf, and one switch profile for every VPC pair. Keep them separate. Next, for every single switch profile you make, immediately create an interface profile with the exact same name. That creates a perfect one-to-one mapping. And finally, and this is a big one, when you need to add a new port to, say, Leaf 101, don't make a new profile. Just go to the existing profile for Leaf 101 and add a new port selector to it. And this is what it looks like in practice. It's clean, right? You can see Leaf 101_SWP maps 1-to-1 with Leaf 101_IFP. The VPC pair has its own matching set of profiles. This way, when you need to configure a port on Leaf 101, you know exactly where to go. No guesswork, no hunting around. It's simple, it's predictable, and most importantly, it scales.
Okay, one last really important warning. You're going to see a quick start wizard in ACI. It might look tempting. My advice? Stay away from it. Don't use it. It seems helpful, but it completely breaks the rules we just talked about. It creates a brand new, throwaway profile for every single port you configure. And before you know it, you've got a configuration that's a total chaotic mess. Always, always take the extra minute to build your policies manually. It'll pay off, I guarantee it.
So let's just end with this question to think about. Learning ACI access policies. It's really not about learning where to click in a GUI. It's about a fundamental shift in your mindset. It's about moving away from thinking about individual ports and switches and starting to think in terms of these reusable, scalable blueprints. So I'll leave you with this. How is this shift from telling a box what to do to just declaring what you want? How is that going to change the way you operate your network?